Hello students. Today we are going to learn chapter 6, that is measure of dispersion. So let's start with the introduction. We saw that the measure of central tendency gives us the bird's eye view of the entire data, and they are called averages of the first order. It serves to locate the center of distribution, but they do not reveal how the items are spread out on either side of the central value. The measure of scattering of items in a distribution about average is called dispersion. Now, the measure of dispersion are also called averages of second order because they are based on the deviation of the different values from the mean or other measures of central tendency, which are called averages of first order. So far, we have looked at ways of summarizing data by showing some sort of average, but it is often useful to show how much these figures differ from the average. This measure is called dispersion. Dispersion is the measure of the variation of the items, and it is a measure of the extent to which the individual items vary. Now, when we talk about the purpose of measuring dispersion, it appears to serve two purposes. Firstly, it is one of the most important quantities used to characterize a frequency distribution. And secondly, it affords a basis of comparison between two or more frequency distributions. The study of dispersion bears its importance from the fact that various distributions may have exactly the same average, but substantial differences in their variability. Measures of dispersions are descriptive statistics that describe how a similar set of scores are to each other. The more similar the scores are to each other, the lower is the measure of dispersion. And the less similar the scores are to each other, the higher the measure of dispersion. In general, the more spread out distribution is, the larger the measure of dispersion will be. So there are ways of showing this dispersion. We have range, interquartile, semi-interquartile, coefficient of quartile deviation, mean deviation, standard deviation, variance, and coefficient of variation. So we are going to study which are the topics which are in the syllabus. So first let's start with standard deviation. The concept of standard deviation was first introduced by Carl Pearson in 1893, and it is the most useful and most popular measure of dispersion. Just as arithmetic mean is the most of all the averages, standard deviation is the best of all the measures of dispersion. The standard deviation is represented by the Greek letter sigma. It is always calculated from the arithmetic mean, median, and mode is not considered. So over here, when we calculate, we are going to calculate from the arithmetic mean, and median in mode is not going to be considered. So when we look at the earlier measures of dispersion, all of them suffer from one or the other demerit. That is, when we talk about range, it suffers from a drawback which considers only two values and neglects all the other value in the series. So quartile deviation considers only 50% of the item and ignores other 50% of the items in the series. Whereas when we talk about mean deviation, no doubt it is an improved measure, but it ignores the negative signs without any basis. Carl Pearson, after observing all these things, they have given us more scientific formula for calculating or measuring dispersion. So while calculating standard deviations, we take deviations of individual observations from their arithmetic mean and then each squares. So the sum of square is divided by the number of observations. The square root of this sum is known as standard deviation. Now, when we talk about the advantages of standard deviation, it is very popular scientific measure, and from standard deviation we can also calculate correlation, etc. Now it considers all the items of the series, and the squaring of deviation makes them positive, and the difficulty about algebraic signs which was expressed in case of mean deviation is not found here. But yes, there are certain demerits. The calculation is difficult, not as easier as range and quartile deviation, and it always depends on arithmetic mean. So it cannot be calculated for qualitative data. The standard deviation is one of the most important measures of dispersion, and it is much more accurate than the range and interquartile range. It takes into account all the values, and it is not unduly affected by extreme values. So what does it measure? It measures the dispersion or the spread of figures around the mean. A large number for the standard deviation means there is widespread of values around the mean, whereas a small number for the standard deviation implies that the value are grouped close together around the mean. Now, this is the symbol for standard deviation and the formula. Now, standard deviation is the positive square root and the mean square deviation of the observation from their arithmetic mean. So we have the formulas over here. Now, we are going to try and find the standard deviation of the minimum temperature of the 10 weather situation in Britain on winter's day. So the temperatures are as stated in the slide. Now, over here, we have to observe the formula and find the things accordingly. So there should be enough space here to fit the number of values. Example, there are 10 temperatures. So we can use the formula wherein the temperature are stated. So summation of all, that is sigma x, summation of that temperature is 50. 50 upon 10 is equal to 5. So this is how we have got the mean, that is x bar 555. Now we need to find x minus x bar. So 5 minus 5, which is 0, 9 minus 5, which is 4, and so on. And then we can find out x minus x bar square, and we get the answers. So now we can apply all these things in the formula. Summation of x minus x bar whole square is 80. So when we see this and apply it in the formula, the answer we get is 2.8. Now standard deviation is much more useful. For example, our 2.8 means that there is a 68% chance of temperature falling within that plus or minus 2.8 degree of the mean temperature. That is one standard deviation away from the mean. Normally the values are said to lie between 1, 2 or 3 standard deviation from the mean. Now this is the example for ungrouped data. So over here the formula x is equal to sigma xi upon n. This is the second example. Now, when we talk about variance, it is defined as the average of square deviation or square of standard deviation of set of observation. Now, variance is the mean of square deviation scores, And the larger the variance is, more the scores deviate on average away from the mean. And the smaller the variance is, the less the scores deviate on the average from the mean. The coefficient of variation, it indicates the spread of values around the mean by percentage. So we can calculate it by standard deviation into 100 upon mean. The higher the coefficient of variation, the more widely spread the values are around the mean. And the purpose of coefficient of variation is to let us compare the spread of values between the different data set. Now, comments on the children in the community. We have height, weight, mean, standard deviation. Now, since the coefficient of variation for the weight is greater than that of height, we would tend to conclude that weight has more variability than height in the population. So the measures of variation are useful for further treatment of data collected during the study, and the study of measure of dispersion can serve as the foundation for comparing between two or more frequency distribution. And standard deviation or variance is never negative. So when all the observations are equal, standard deviation is zero. And when all the observation in the data are increased or decreased by constant, then the standard deviation remains the same. Thank you.